G'day, my name is Matt Baker with Polara. Thank you for spending a few minutes with me today. So I just share a short presentation with you about our new iNavigator S line that we've added as a revision to our current iNavigator platform. So this is presupposing that you are familiar with our iNavigator APS equipment and with APS in general. If you don't know, we have a facility outside of Dallas, Texas. Our product is made in the USA. So our newest version of our iNavigator is called the iNS, adding the S for a significant revision to the Navigator, and it supersedes the iNavigator platform, and it's really a backwards compatible revision to the iNavigator that you are familiar with. And I'll go over and share some of those changes with you and tell you how it'll benefit you to transition over to the iNS system. You may be familiar that there's two kinds of basic APS configuration systems out there. There's a PED based system that's used more in areas where there are pre-timed non-actuated signals that maybe never had even buttons on the pole. So this allows you to operate an APS without having the two button wires. You have a control unit in the PED head that takes the power and the walk and don't walk from the PED head, steps it down 24 voltage, low voltage DC down to the button, and allows the button to, when pressed, give the feedback based on the actual pedestrian signal. There is still two terminals here for button call wires if you would like them. The system that most people are familiar with is our two-wire central communication system, and in that platform we have a shelf mount unit, and then we have a card unit for 300 series cabinets, and I'll kind of go over that as well. So the big change is this button, one button, can act as a PED head based system or as a two-wire system if you buy the iNS 2 version of the button. It is important to note that it is the same software, firmware platform as the iNavigator. The same Polara field service app has been updated to work with the iNS system and your current iNavigator systems. So it is backwards compatible. The biggest change is we've added Bluetooth 5.0. When you upgrade to Bluetooth 5.0, this gives you capability for multiple devices and multiple users, and I'll talk a little bit more about some of that application. One of those applications is this PED app that we've created, which is a smartphone app for pedestrians to help them locate the button and get actuation from their phone and crossing feedback, and I'll give you a little demo of that later. We have changed the design slightly too to make it a little bit easier for installation and maintenance as well. Just wanted to stress and reiterate that again, it is backwards compatible, and recommend that you try it in place of your current iNavigator platform. The buttons essentially look the same. The central control unit does have some changes to it, but again, please remember it's backwards compatible, and I'll show some more of that. As people move and traffic moves more towards connectivity, the demand for more capability in that area is growing. So again, this is another reason we wanted to add the Bluetooth 5.0 into our system. So this new modular design, as you can see on the left, it's designed to be modular and also allow the speaker to be field replaceable if needed. So I'll just give you a little bit of a demo with the actual product. So when you receive the product for installation, I've taken the 4 screws already out of the faceplate, out of the sign. Now of course this is a 5x7 sign. If you have a 9x12 or 9x15, then we will send you a back plate that allows you to mount the larger sign on there. So I also have taken the bottom screws out of the bottom cover. So if I remove that, you can see the button and your termination area. Now for installation, there's one more screw in the bottom here. It's a grounding screw. Once you remove that, you can actually take the back off, and now this is very easy for installation. You can hold this up against the pole, get your alignment right for the arrow into the crosswalk, and then as you can see, there's a couple of ways you can mount this. We have the traditional slotted holes. The 6-inch center to center mounting is the same as our previous Navigator APS. And then we've also added holes or slots for banding straps so that you can band this to the pole. The point is, it's very easy now. You can hold it up to the pole and mark it and set it up for your drilling and tapping. And then once you mount that to the pole, you can take the rest of the unit and it just slides back onto those mounting bolts there. So once you've done that, you can then put your sign back on, and then also do your termination and put your bottom cover back on. So again, on the back, we've left this little wire chase so that the wire can come down the pole and then again come up and around the front, forming a natural drip loop as well. A couple of the other changes. Let me advance the slide here real quick. So again, you can see that easily designed, and again, see how this mounts to the pole as I explained. As far as the size difference, as I mentioned, there's a slight size difference. It's about 1/2 inch longer than your current iNavigator button. But as you can see, if you were walking down the street, unless you were very clued into on our design, you probably wouldn't recognize that change. As far as on the bottom of the button, again, when you pull this bottom cover off, there's 2 screws added now to where you can loosen and take the arrow out and rotate it. So very easy. And I also wanted to show you what's behind here. You can see there's actually nothing behind. This is because we have used the Hall effect switching system. So basically there's no contact. This will bottom out on the stops, and it's a non-contact proximity sensing switch, the Hall effect. And so there's nothing really to wear out behind there. The benefit again of having that switching system is in our app, our Polara field service app, you can actually change the actuation pressure or force to actuate the button. There's a soft, medium and firm between 1 and 3 pounds, 3 pounds being the maximum. So the ADA requirement is 5 pounds pressure or less to actuate, and we're already giving you a max of 3, so you're well below that. But think about maybe the elderly in the past who haven't been able to feel comfortable pressing that button. You can actually dial down that pressure as well. Go back to this previous slide and give you a close-up of what's on the bottom of that button. So on the left of every button, you have your 2-wire button call wire terminals. And then if you order our iNS 2 version of the button, again, as I mentioned, that can become a 2-wire or a 3-wire. So there's a 3-wire terminal block here that you can add your 3-wire cable, which is power, ground and data, back up to the control unit in the ped head, and quickly have this button operate without not having to have button call wires. One of the other changes that we've made by going to that Hall effect is that when you press the button, you see actual travel. So psychologically, people now can feel something happen, whereas our EasyComm system had a piezo switch where you really didn't feel that movement or travel. This button here now, it's a very light, easy touch, but you're feeling some movement or travel there. On the back, we've got the speaker, holes protecting the speaker. So the speaker is rear facing. However, as you can see on this diagram, there is now sound coming out of the front as well, but it's well protected. So once that sign goes on the button, the sound is coming out of this little grate area here, but if they try to stick something in there, you can see that the speaker is in the back here and it's well protected. And as I mentioned with the speaker, it can lift out and be field replaceable. We also have more ambient volume adjustments with this system. Another thing that comes from having the Bluetooth in our buttons is I wanted to share with you a possible scenario that you might have one day in the field. And this is where if you want to use our 2-wire system and have a central control unit in the cabinet, so all these buttons here are 2-wire buttons, they're all communicating back to the cabinet over the 2 button wires. However, in this example, you may have a situation where you don't have conduit with the button core wires, but you do have your ped head signals. So you could have these 2 buttons, number 6 and 7, on phase 2 and phase 4, running off the ped head with no actuation wires. But with our Bluetooth, we've added a feature called wireless sync into our ped Polara field service app. And that allows you to go into these buttons here and program this button to be phase 4 and this button to be phase 4. So when someone pushes this one, it'll send out a Bluetooth signal, check its phase partner, phase 4, and actually do a remote ped call to that button and turn on that button as if it's been actuated. So the sounds will be synchronized, and also a call can be placed back to the cabinet over those 2 button wires. Now this allows us to work between the 2 and 3 wire buttons, and it'll work on your current iNavigator system as well if you do a firmware upgrade. So we support 3 wireless programming platforms, the Apple or the iOS, and that includes iPhone, iPad, iTouch, or iPod Touch, then the Android platform, and then also a Windows platform, including a laptop or a tablet, where you do need to use a Bluetooth dongle that we would supply you. So one of the changes with the Bluetooth is we've put the 5.0 chip right here to give us the best signal strength and to lessen attenuation because of metal that's around it. So what we've found with the new Bluetooth 5.0 and the positioning of that chip is that firmware upgrades are significantly faster, approximately 50% faster than previous. So here's a couple of the other changes with the central control unit. The one on the left is the system you may be familiar with, where we've had a 50-pin 4-cable harness assembly that allows you to physically hardwire in and connect to your ped inputs and also receive your ped interval timing from the controller. That 4 cables also included a preemption cable and a general purpose cable, which many agencies or customers have not used. So one change we've made is we've gone to a separate cable system here. So we've eliminated the 50-pin harness, which actually has saved some cost, which will be reflected in pricing. And also we've separated the cables here. Other than that, you can see we still have the LCD backlit panel and the SDLC, USB, and Ethernet port. So here's how those different cables work. First of all, there's a button PLC cable that goes down and connects to the interconnect board. So the interconnect board between the 2 systems is the same. So that button PLC cable will come down to the interconnect board in the cabinet where you land your field wires, and that will do the power to the buttons and the power line communication. Then the 2 most important cables will be cable C, which is your ped call inputs, so it's 4 channels that you are already familiar with, and cable A, which goes to your load switch outputs that gives you your ped interval timing. And then you can see in this example we've got the SDLC cable, and I'll talk a little bit more about that as well. We have added a system where you can buy only what you need. As I mentioned, typically the general purpose inputs and the preemption inputs haven't been used by many customers, so why have that in a cable or in an order if you don't really need them? As far as your configurations, the shelf mount unit will operate in any cabinet that it can physically fit into, because again, you've got a cable A which places your ped calls, cable C which places your ped calls, cable A receives your ped interval outputs. and then your button PLC cable. So we have created a cable package, and I'll go over that here in a minute. So that's your hardwire TS1 type example. If you are running TS2 and have the capability for SDLC, you can do what we call a split configuration. That's where you can use the SDLC to receive ped interval timing from the controller without doing any programming on the controller. In our app, you will assign and match your load switches, and that'll be it. And then of course your button PLC cable, and then cable C to still wire into your physical ped inputs to place the calls. If you want to go full BIU, SDLC, our ICCU-S2, so the new model is called S2, the previous model was called ICCU-S. So this new model can be a full BIU as well as your previous -S model. The difference is, again, we've changed to go to separate cables. So if you want to act as a full BIU, you can now place ped calls to the controller via SDLC. It does require you to remap the controller to see vehicle ped calls or vehicle calls as ped calls. So this would be a detector act BIU 1 through 4 assignment in our app, and then you will be doing a logic statement of some kind in your controller to have it see the vehicle calls become ped calls. And then you have a button PLC still, and we'll give you a logic ground cable to make sure that there's no floating voltage when you're in an SDLC situation. So I mentioned cable packages. So to get any system up and running, you could order this ACCP, any cabinet cable package. That will give you the interconnect board, cable A for your load switch outputs, and cable C. Your button PLC cable comes with every ICCU. So you can order that package and simplify your ordering system and your installation. Then if you want to do either the hybrid, half SDLC to receive your ped interval timing but still want to place your physical ped calls, you can order this SDLCC package, and that will add a Y splitter cable and the other necessary cables. Back to the ped head based system, one change, if you're familiar with our 3-wire ped head system, is the ped head control unit has a slight change to it. It is compatible with existing IN3 push buttons, so if you need to replace a ped head control unit, this will fit right into the ped head and replace the other system. We've added extra transient protection to this as well. So this is what it looks like in the ped head. Again, you're taking your high voltage, putting it on one side, and then we're going to step it down to ground, power, and data down to the button. So we've combined walk and don't walk over the data cable. We can supply you with 12, 25 foot or 50 foot cable options, or you can supply your own IMSA rated cable. The whole goal of having the wireless programming was to give you the flexibility based on the signal strength to possibly be sheltered during inclement weather conditions. So once we started our new iNavigator platform, we offered free voice recording. On our website, we have a audio library where you can actually request us to record voice messages for you. We will store them in our database and also email them to you. You can, in your app, you can actually open that file on your email and save it into your app, and it'll store all those sound files. You can literally have every voice message for your whole agency in the app. And then in the app, you can actually shoot that out to a technician that may be in the field that needs it, and then he can open it in his app and Bluetooth that message into the button. We also do have the audio extract. If you had a knockdown on one side of the street, the button on the other side of the street has the same message. You can actually, with the app, extract that message out if you didn't have it in your saved file and transfer that back into your new button. So the things that you can do wirelessly is firmware updates. You can get button usage information, time of day programming. Just quickly wanted to also mention that we have added a new APS version for RRFBs. The FHWA allows an APS to be on an RFB to provide, again, audible indications for visually impaired. So we have a version called the iNS. The X is for mid-block crossings, AC or DC. The difference is this button, it does play a locator tone, but when pressed, it does not say walk sign is on or give a vibro-tactile response. What it does is it lights up a yellow flashing LED in sync with the RRFB flashes and plays a message, yellow lights are flashing twice per the FHWA standards. What this button does allow us, if you're familiar with our previous version called the Model X, is there is no control boards needed. Now there's just 6 cables or 6 wires, 2 for the lights, 2 for the button, and power and ground. So it does save cost, and this also has the wireless syncing capability that I mentioned earlier. So for example, if someone presses this side, you can program this button to be phase 2 or whatever you like, and the other button to be phase 2. When that button is pressed, it will send a Bluetooth signal and turn that other button on and actuate the other side. So theoretically, that could also save the cost of a radio transmitter that is typically used in an RRFB situation. This will also include the ability to work with our Ped app that I mentioned earlier for pedestrians. There's another example of the different configurations it can work with. So, talking about connectivity again, we want to be a part of that and provide as much connectivity and as much help to pedestrians as possible. So with that, I just want to introduce our Ped app, and this is a separate smartphone app that we've created, and again, it's a supplement. We never want to replace the physical button device. You cannot count on everyone having a smartphone, but going to the different conventions that we do to support the American Council of the Blind and Veterans Association, there's been demand and requests for smartphone apps to help them locate and actuate the button. It's only compatible with our new Bluetooth 5.0, which is the new iNS, and what it can do is provide intersection crossing information. So as you come up to the button, if it's been programmed, it can come up on the app and give you the crossing options, allows you to actuate the push button, and then provide same information that you'd get from the button. So you would hear an audible indication on your phone, and I'll play a little video here that demonstrates that. The important thing is it is controlled by the agency. The agency has to set it up in the buttons for it to be used, so it gives you some level of control. One thing I recommend is, if you want to try it, think about the people that are requesting the APS from you. Those are the people that you know will use the equipment, and then potentially they could use this app and benefit from that. It also works with existing text-to-speech. So in the smartphones, they have a voiceover that gives you the voice indications of what program and app you're using and processing through that app. So let me just play this video and give you an example of what that looks like.
Ped app. Double tap to open. Use 3D touch to show home screen actions. Ped app. Look for intersections. Switch button. Off. On.
So you can see it's looking for those 2 buttons, assuming that this would be a corner.
Corner of North Main Street at East Ontario Avenue. Travel west across North Main Street from the northeast corner of the intersection. Travel south across East Ontario Avenue from the northeast corner of the intersection. Travel west across North Main Street from the north. Selected. Travel west. The volume of the selected unit's locate tone has been increased. Continue walking towards the intersection. A call has been placed to cross the street. Wait for the walk indication before walking.
So you can see from that presentation, you may have noticed the person swiping on the phone, the visually impaired are used to that program, they're used to that voiceover program. So it told them audibly the crossing choices. They can swipe and determine which one they want. We have a message that comes up in the device when they first open it that tells them that this is a supplement, that we always recommend you still determine your location with a physical button and your orientation with that. And remember that this is a supplemental device. One last feature I just wanted to share with you again is when it comes to APS, one of the biggest challenges is that noise, is that locator tone. So we have the feature called Quiet Time, where basically 3 button clicks, you can turn on Quiet Time, give it a start time and an end time, and then what kind of volume reduction you'd like it to play. And it will go ahead and reduce that volume based on that time period in 3 easy clicks. Also, just to let you know that we have different mounting options. Some are to help extend your reach if you're having trouble getting that button to be within the ADA reach requirement. So we have straight extensions, 6 and 12 inch, and also angled and curved. As you can see, there's sometimes you get different mounting applications that make it a little difficult to get your mounting height. We also have a 90-degree adapter that allows you to rotate the button from an extender and give that access and alignment again with the crosswalk. And also we have the extenders if you use 9x12 or 9x15 signs on a 2.90D pole. This gives you the spacing clearance to mount those so that you don't have to mount one upside down. And that is my shortened version of the presentation. Hope that helps. Please feel free to contact your local distributor or Polara for any other assistance or information you may need. Thank you.